This is Jude, Assistant Professor, Department of Physics, St. College of Arts and Science, Cuddalore. So we can see in the introduction to optic fiber communication system. So what is fiber optic communication? It is a method of transmitting information from one place to another by sending a light through a optical fiber. So the information is carried out by the light in medium as then it is used as optical fiber. The light forms an electromagnetic carrier wave that is modulated to carry information. So here the carrier wave is in the form of light and it is modulated according to the information, and it is carried out through an optical fiber. And this process of communicating fiber optics involves these fundamental steps: creating an optical signal using a transmitter, relaying the signal along the fiber. So after that, ensuring that the signal does not become too distorted. It is very important that the signal, as the information is carried out by the light, it should not be attenuated or distorted or weak while receiving the optical signal and converting it into an electrical signal. So it is also very important, so we can ensure that there is no distortion occurs. And optical fiber is made up of a glass or a plastic fiber that carries a light along its length. As we know, the medium is optical fiber, so it is made up of either glass or plastic. The light is kept in the core of the optical fiber by total internal reflection. We all know that the fundamental idea or principle behind this optical fiber communication is total internal reflection. The information carried out by the light is again and again reflected back into the core. It means into the medium, so maximum attenuation or distortion can be reduced. The optical fiber consists of a core, cladding and protective outer coating which guides light ray along the core by total reflection. This total reflection is carried out by the core and cladding, which is act as a protective layer which reduces the attenuation. And core is thin glass center of the fiber where the light travels. So it is the center part of the optical fiber. This is a thin glass center which the light travels. Cladding means it is an outer jacket which protects it, and there is a buffer coating also. It is a plastic coating. So the important point over here is the core and the lower refractive index cladding are typically made up of high quality silica glass. So due to the reduction in the attenuation, as we ensure that we have to check the core which should have a lower refractive index cladding. The material has to be low refractive index, so we can make it using a high quality glass. Then both are made up of a plastic as well. And another important thing we should take into account is the critical angle in which the light has to be traveled. Critical angle means the minimum angle of incidence in which the light ray strike the interface between the two media. As a result, the angle of refraction is 90 degree or greater than it, which basically satisfies the possible total internal reflection principle. So this is the critical angle in which the light has to be traveled. So what is the alternative for this normal communication system is the optical fibers, using optical fibers, which has the exclusive advantages over normal communication system. So obviously it is less expensive and the quality is really high. The signal, the attenuation or distortion is very less. The light has to be, since the light carries the information, so the speed should be high. Another one is non-flammable and it is lightweight. The another important advantage over here is higher bandwidth. Thousands of channels can be multiplexed over one single fiber. Since it has a higher bandwidth range, the noise is very low, and it has ultramagnetic interference EMI. Safety doesn't it interfere with the electrical signals, and so we can ensure that our environment doesn't get damaged. And disadvantages, the interfacing equipments that converts the electrical signals to optical signals, that is spilling. That always a problem for us. That is the disadvantage in optical fiber communication system. And the important parameter is numerical aperture of the optical fiber. It is used to describe the light gathering or light collecting ability of an optical fiber. So numerical aperture is an important parameter in connecting or selecting an optical fiber, which is used to transmit the light signal in carrier wave of an optical system. Is a dimensionless number characterizes the range of angles over which the system can accept or light emit. This numerical aperture decides the characterization of the carrier wave, means the signal has to be carried from one end to another end. And it is characterized as single mode and multi-mode. Single mode fibers used to transmit one signal per fiber. As the name refers, it is a single mode fiber. So transmission occurs, only one signal is allowed to transmit. So they have a smaller cores of 9 microns in diameter. Infrared light from laser has to be used to travel to take the signal from one end to another. As the name indicates, the next one is multi-mode fibers. Multi-mode fibers used to transmit many signals in single fiber. Usually computer signals are used to travel through these fibers, and they have a larger cores comparatively with single mode. There are 62.5 microns in diameter, and usually infrared from a laser and LEDs can be used. However, multimode fiber introduce multimode distortion, which limits the bandwidth and length of the link. Furthermore, because high dopant content, multimode fiber is usually more expensive and exhibits higher attenuation. As multi signals are transmitting in a single fiber, definitely there may be a interference or distortion occurs due to the high dopant content. Several signals are carried through a single fiber. Definitely, it has quite higher attenuation and more expensive. Single mode fiber, smaller core, less than 10 micrometers, and necessitates more expensive components and interconnection methods, but allows much longer and higher performance range. Single mode fibers somewhat advantage over multi-mode, and quite it is expensive when comparing to multi-mode. And next one is index profile. The index profile of an optical fiber is a graphical representation of magnitude of the refractive index across the fiber, which refers how a signal gets traveled from one point to another point, from transmitter to receiver end. The refractive index is plotted on the horizontal axis. When you can see the diagram, the graph, we can easily denotes how much the magnitude of the refractive index can come across through the fiber. The boundary between the core and cladding may either be abrupt in step index fiber or gradual in graded index fiber. These boundaries are taken into account between the core and the cladding in step index fiber as well as in graded index fiber. A step index fiber has a central core with a uniform refractive index, and outside cladding has also a uniform refractive index surrounded the core. Both the refractive index of the center core, that is core, and the cladding should be same. The uniform, it should have a uniform refractive index. However, the refractive index of the cladding is less than that of the center core. This is very fundamental. How we can always have the cladding less than that of the core. The refractive index of the cladding should be less than that of the